Good morning. Today we are working on CO49. I can create a function table. And we're going to see how this function table tomorrow with our next objective when we do CO50. We'll see how that function table ties into graphing. So we've been working with our XY coordinate pairs and graphing them and finding the slope. Now we're going to learn about the function table and how we use that function table to work with those graphs. So today it's going to be just focused on the function table part. So when we have a function table, we have certain parts to it. The first part is the input, what you plug into an equation. We could say that is what is being tested. So the input is what you're putting in, what you're testing. You're putting something into the equation. The output is the result of the equation or the test. And we're going to see what that means in a minute when we're actually doing it. So we're going to have inputs and outputs. So the function table, the actual table, is a way to organize multiple inputs and outputs. And that's how we get ordered pairs for a graph. So we use that function table to get our inputs, and our inputs are going to be our x's, and we get the output is going to be our y's, and we use those to make ordered pairs to graph our function. So the equation we get from a function table is also known as the rule of the table. And all of our inputs follow the same rule. So we do the same thing to the x, and we get the y. So we're going to create a function table with at least 4 inputs and outputs for each equation given. So they're giving us the rule for every function table. We need to create the function table based on that rule. Remember, and this is going to be important, and I'm going to show you on one of these why this is important. You get to choose the inputs, what you want your x to be, to create your function table. And we want to be smart about it. Okay, we want to choose x's that are easy for us to use for our equation. So we're going to make smart choices. If I get to choose 4 inputs, I'm going to choose 4 x's. Am I going to choose a number like 125? No, because that's a big number. Why do I want to complicate my life? I'm going to use numbers that work well so I don't overcomplicate it. Keep it simple so you don't make those simple mistakes. So I'm going to scroll up so we can see what that means. We're going to create a couple of function tables together using the rules that were given. So let's start with this first one. We always have our input and then our output. The input is our x, I said, and the output is the y. So for right now, I put input and output so you got an understanding of it. Really what we need to know is the X is what we're putting in, the Y is what we're taking out. So we don't have to have it labeled input, output, but we need to know the first number is the input, that is our X. The second number is the output, that's the Y. So let's look at our equation. I'm just going to write it over here so we can see it nice and big. Y equals X plus 1. Now he said we need to have at least 4 inputs and outputs. So I'm going to draw lines across so I can have 4 entries. So that's my function table right here. There's that function table. Make sense? Have we seen function tables before? Kind of remembering them from last year. You did do it in 5th grade, but it's been a while. You will see these on map tests. You will see these a lot next year too. In the year after and the year after. Function tables are important for us to know. Every function table has a rule that you have to follow. You're going to do the same operations to every X, and we're going to see how they go up. So, who can give me an X that we want to use in our equation? Gigi.
3.
All right. So if I put 3 in for X, I'm going to put that 3 into my equation for the X. What does my Y equal?
4.
4. So if I put 3 in for X, I get out of it a 4. So I'm going to solve my equation for Y. Y equals this. I have to solve it for Y. So that's 1. I have to do this 4 times. What other number should I use, Jillian?
1.
1. So Y equals 1 plus 1, because I put the 1 in for the X, and I get 1. I always have to add 1 to that X. So what is Y if X is 1? 2.
3.
You see how we got the X and what the Y equals? Keep your feet down, please. Aiden.
6.
All right, so now we want to put a 6 in for X. So we're going to say Y equals 6 plus 1.
7.
Y is 7. One more, because I need 4, at least 4 in my table. Nolan.
4.
Okay, if I put 4 in for X, I have Y equals 4 plus 1. What is Y? It is 5. 4 plus 1 is 5. Luciana.
Do you want us to put both the equation and the chart?
So what I am checking for, what your answer is going to be, is the function table. So you need to fill in all the parts of the table. Sometimes we have an easy rule that we can kind of do in our head. And we can do the mental math of, okay, it's X plus 1. So if I put in a 2, 2 plus 1 is 3. You don't have to write out all of the work. You can write out the work if it helps you. What I'm looking for is the answer, because it doesn't say that you have to show all of your work, because a lot of this can be mental math. But this is what I'm looking for. I'm looking for your function table. It's got to have 2 columns. You have to label it. The first column is always X. The second column is always Y. Just like with our ordered pairs, it's always X, then Y. On the function table, it always starts with the X and then it's the Y. And just know that that X is what you're putting in. It's your input. You put the X into the equation and you get the Y out of it. Jillian.
Do we have to put like 3, 1, 6, 4 in order or no?
You don't have to organize it. Myself personally, what I do is when I do it, I go, okay, my rule is 2 times X. So I'm just gonna, because my brain likes to be ordered, I'll just do 1, 2, 3, 4. Say, okay, I've got my X's. Now I'm going to figure out the Y's for each of them because I like to be organized and ordered. I would put it organized and ordered. On the test, if you give me something like this where they're not organized and ordered, you'll still get it right because I'm not expecting that you put it organized for these function tables. I like to be organized myself. So this is what I did when I was creating the answer key. And then I said, okay, if I put 1 in for x, 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8.
How would you 2? Oh, wait. Oh, I understand.
And then you see that there's a pattern. With function tables, because we are doing the same rule, you will find a pattern. If you go organized, it makes it really easy to see what the pattern is. If you are not organized, it's hard to see your pattern. But if you go in an organized manner, you can see, like Jillian just looked and said, oh, it's 2, 4, 6, 8. You can see what that pattern is going to be. So if you organize it, it does make your life a little easier.
So we don't have to put like the y equals and x equals?
No, this is what you do if you're not sure with the mental math. You can write it out. I am not checking to see, because some of us can do it as mental math, some of us want to write it out. This was me showing you what we're doing to make sure you understand it. Some of us are ready for that mental math part. You don't have to show it if you don't need to. Here is, we're choosing the smart ones come in handy. Let's look at this one. There's a fraction. If we're going to be graphing, is it easier to graph a whole number or a fraction? Whole numbers, right? Whole numbers are much easier to graph. Let's just pay attention, gentlemen. Whole numbers are much easier to graph than fractions. So if we get to choose what our x is, let's choose numbers that are going to give us whole numbers. So let's look at what this function table might look like. So you always have to have x, y at the top. We need at least 4 entries, so I'm making 4 rows. So first step is to draw your function table. Then we're going to decide what we're putting in for our x. I see that my denominator is a 2. Why does that matter why I'm thinking of what my x's could be?
Divide by 2?
We're going to be dividing by 2. So what kind of numbers do I want for my x? JT?
Like 1.
So if I have a 1 for the x, is that easy to divide by 2? Is that going to give me a whole number? Because remember we said we're going to be graphing these in our next objective, and it's easier to graph whole numbers than fractions. So if dividing by a 1 is not going to give me a whole number, could I use it? Sure. But do I want to make a smart choice and use an easier one? Yeah. What kind of numbers would I want to use, Taya? Even numbers. Why, Taya?
Because you can split them in half.
Because they're divisible by 2. So I'm going to look at this and say, I want to use numbers that are divisible by 2. So I'm going to put my x's to be those even numbers. So when I plug it in, it's going to give me a whole number as an answer. So 2, I'm just going to write it out here so we can see what that is. 1/2 times 2, we know we put a 1 underneath it. You can cross simplify real easy and say we can divide out a 2 and a 2, so it turns into a 1. 1 times 1 over 1 times 1 is 1, right? Do you guys remember that cross simplifying? The long way would say 1 times 2 is 2, 2 times 1 is 1, or is 2, 2 over 2 equals 1. Now we're going to put the 4 in. So 1/2 times 4, which is 4 over 1. If I divide that 2 out, that becomes a 1, that becomes a 2, and I get 2 for an answer. Working it out the long way, that's 1 times 4 is 4, 2 times 1 is 2, 4 divided by 2 is 2. So if I put a 6 in, it's 1/2 times 6. 1 times 6 is 6, 2 times 1 is 2.
Please park this very important announcement. The soccer field will be closed for recess due to some unpleasant water. Soccer field will be closed for recess. Playground is open. Any questions? Call the office.
So if we have 1 times 6 is 6, 2 times 1 is 2, 6 divided by 2 gives me the 3. So then our last one, remember what I was saying with Jillian, if you stay in an organized manner, you can see the pattern easily. I did 2, 4, 6, 8. Do I know what the 8 is going to be, Bennett?
Yeah, because it's just half.
Yeah. So 1, 2, 3, 4. I know I'm having my x's. 6 or 2 is 1, 4 is 2, 6 is 3, 8 is 4. So I'm having them.
It's the same thing as the other problem, just reverse.
Yeah.
Oh.
So when you're working with the fraction, use the x that's going to give you a whole number that's divisible by that denominator. We wanted numbers divisible by 2. Here we're going to want your x to be numbers divisible by 4, numbers divisible by 3, numbers divisible by 5. Okay, so think about what those multiples are of 5, the multiples of 4, the multiples of 3. Keep it easy, right? You know, if you end up with 9 divided by 3, it's going to give you an easy x. Okay, we don't want to work with improper fractions, mixed numbers. That just makes it more complicated. Keep it simple. Work with the numbers that are going to give you the whole number for your y. Taya.
Y equals negative 5 times n plus 1.
Mm-hmm.
You can make the x a negative because the negatives cancel each other out.
Yeah, you sure could. Okay, so what Taya's saying is, oh, I like working with positive numbers. Positives are so much easier for me. So I want to make sure that that negative 5 times a negative number, so I have a positive to work with. Be smart. Make smart choices.
Smart one.
Any questions? Matthew,
There's number 4.
this one?
Yeah.
X minus 10?
Yeah.
So we're going to do the same thing. We're going to set up our function table. I'm going to put my X and my Y. I'm going to put 4 rows because I need at least 4 entries. Then I need to decide, what do I want my X's to be? If I'm comfortable working with negative numbers, I could do 1, 2, 3, 4. And I could say, I know what 1 minus 10 is. It's going to be a negative number, right? Maybe, like Taya was saying, I don't want to have to work with negative numbers. What kind of numbers am I going to choose for my X, James?
You just do 11, 12, 13, 14.
Yeah, you can choose numbers that are bigger than 10. So you know your answers are going to be positive. 11 minus 10 is 1. 12 minus 10 is 2. Right? If we chose to do the 1, 2, 3, 4, oops. If I did 1, 2, 3, 4, because I like those numbers, if I did 1 minus 10, I would get negative 9. 2 minus 10, I would get negative 8. It's going to be the same pattern that we're going to be following on that number line. It's just you have to be comfortable working with your negative numbers. So if you don't like working with negative numbers, Choose smart ones. Choose numbers for x that are going to be bigger so you don't have to worry about negatives. You get to pick what your x and your y are. It's going to be the same pattern. James?
So basically for that one, you're just trying to make stuff that equals 10, basically, like that.
Well, you have to do x minus 10. So you're not trying to equal 10.
Yes.
You have to put in an x that you can subtract 10 from. So use a number that you're comfortable with to subtract 10 from. Riziki. 3x minus 8. So first step, make your function table. X and y. You need 4 columns. So we need to plug a number in for x. For this one, I'm going to use my 1, 2, 3, 4. That's kind of my standard go-to. And then sometimes I look at it and go, oh, wait, that wasn't a smart choice. I might go back and erase it once I try plugging it in and realizing it's not going to work. It will work fine for this one. So I have, my equation is y equals 3x minus 8. So if I plug a 1 in for x, I know I'm going to multiply and then subtract, because I'm going to do PERMDAS. You do multiplying and dividing, then you do your adding or subtracting. So what is 3 times 1?
3.
And then I need to minus 8. Oh, I need to be comfortable working with my negative numbers. Okay, so if you're okay working with those negative numbers, you can do that 1, 2, 3, 4. 3 minus 8 is what?
-5.
What was it?
-5.
-5. When we say it with our hand over our mouth, sometimes it's hard to hear. So 3 minus 8, if I'm on that number line at 3 and I subtract 8, I go all the way to -5. So then I would put -5 here. What if I don't want to work with those negative numbers? What should I do with my x? Matthew?
Put higher numbers up.
I can use bigger numbers. I could say my next one, instead of saying 2, maybe now I'm going to say 5. So I could say y equals 3 times 5 minus 8. So 3 times 5 is 15 minus 8. Oh, that I don't have to go into negative numbers. That's easier for me. 15 minus 8 is 7. So if I put a 5 for the x, I would get 7 for my y. So you have to decide for yourself, is it the numbers that you plug in for x, are they easy for you to use? Some of us were able to come up with those negative answers right away. Some of us said, I don't want to do negatives, so I'm going to pick bigger numbers. It's your choice what works for you, because the pattern is going to stay the same. Please put the glue bottle away. It's math class. We don't need it. Any other questions? So remember, you need 4 entries in each function table. All right. I am going to ask, because I notice a lot of us have really gotten into this, we're not going to decorate our empty spaces on our pages anymore. Why do I not want us decorating empty spaces? Not distracting. Some of us can handle it, Luciana.
Because then you don't know if you got the answer wrong. Right.
Well, if you're just writing an answer, you're right. So what do we need to use those empty spaces for, Melina?
Work stuff.
Yeah, to show your work. Because sometimes you have to do multiple steps and it might not be so easy to do it in your head, and you need that space to show your work. You have the space on the page. You also have the space on the back side of the page right next to it. That's all workspaces. So as we're moving forward in math now, I'm going to ask that we're done doodling and decorating in our empty spaces, so we have it available for us as workspace if we need it. Okay, does that sound fair? So we're done doodling and decorating empty space.
What if we do it the day after? Does that look good?
I'm going to say we're just done doodling and decorating the empty spaces. So for my friends at home that are watching, we hope you are well. We hope to see you soon. Have a wonderful day.